Firstly, we'd like to acknowledge that we are meeting on the land of the Kulin Nations and pay our respects to their elders, past and present. Welcome to the monthly Beyond Zero Emissions discussion group. My name is Anthony Daniel. I am a presenter on the BZE radio program that's on Friday mornings on 3CR at 8:30 and also on Monday afternoons at 5:30 and also podcast. We would like to thank the University of Melbourne Energy Institute and Zero Carbon Australia project partners for this great venue that they provide for us every month. For the people that haven't been to one of our discussion groups, BZE is a climate solutions think tank and research organisation. Our goal is to transform Australia from a 19th century fossil fuel-based economy to a 21st century renewable powered clean tech economy. Our projects include Zero Carbon Australia research, Green Power Australia talks, media work, education programs and much more. We're always looking for more volunteers, so if you'd like to come and speak to us afterwards about that, we'd love for you to get involved. The discussion groups are for climate change solutions with presentations by experts in their field, held on the first Monday of every month. Just before we introduce today's guest, we have a raffle at the front for the Radiothon, which keeps our radio show on the air. If you'd like to contribute to that by buying some raffle tickets at $3 for $5, one for $2. And you go on the draw for this, which we're going to draw at the end of today's session. So if you'd like to duck out during this time, you can do that now, get your name down, and we'll draw it at the end. So tonight our topic is how to cheaply and comfortably heat your home with renewable energy. Tim Forcey presents how your home, business or institution can save money and be part of the fuel switching revolution. Tim's research at the University of Melbourne has found that switching from gas to electric reverse cycle air conditioners could create huge money saving opportunities for homeowners, renters and even small businesses. The research is particularly relevant as the Victorian government decides whether or not to open the state to broad-scale unconventional gas mining. Tim has over 30 years of experience in industrial energy with companies such as ExxonMobil, BHP Billiton, Gemini and the Australian Energy Market Operator, where he led the 100% renewable energy study. He's also a stalwart volunteer for BZE, ATA, Bayside Climate Action, and has led many community actions as well. Please welcome Tim.
Thanks folks for coming along on this cold night. When you get home this evening, how many will be heating their house with a heat pump? So there's a few. So a few of you know how it works already. But I do want to investigate if we think this is a good way for keeping the beer cold. I think it's going to work. If you've got a heat pump and you've been using it for heating, you walk outside, you'll feel the air coming out of this thing is frickin' freezing because that's how it works. It's sucking heat out of the air around it. And so the air that ends up coming out of here is very, very cold. So I do a lot of consultation with people in their homes about how they can save energy. And often you'll find people have a beer fridge, and so you encourage them to shut down the beer fridge. And in fact, here what we have here is a beer heat pump. So in the wintertime, you could go put your beer out there. But actually, it might even freeze if it gets cold enough. I think that's possible.
As long as you got honest neighbours.
And honest neighbours, that's right. We got to hear. Now the other thing I've got here is this is the Aruru Sarara Facebook discussion group. So if people are on Facebook, we've got about 115 members there, and Richard's there, and me was there, and Matthew Wright's there, and I'm there, and Alan Pears is there, and lots of folks are there on the Facebook discussion group, the Aruru Sarara discussion group. And with that, I think it's one of the best forums that I've seen for people sharing ideas about what to do in the home in terms of energy. And switching off of gas to electricity is one key thing that we talk about. So if you're interested in getting on there, people are uploading floor plans and asking questions and trying to figure out some of the intricacies of how you can control your air conditioner with a Wi-Fi or whatever. Some of it goes beyond me. But you might be interested in joining us at Facebook. All right, here's tonight's presentation. Reverse cycle air conditioners, Australian renewable energy giants. Actually, this presentation is already on the internet. BZE, Jody loaded it up with BZE Energy Freedom some time ago, most of it. And in fact, if you Google renewable energy giants, when I do that, the number one hit is this presentation. So that's pretty cool. So just go home and Google renewable energy giants and you should be able to find it. A little bit about me. I grew up in the state of Pennsylvania in the States, and one of my first jobs off the dairy farm was working in the strip mines of the coal strip mines in Pennsylvania. So that's what I used to do. And then I trained as a chemical engineer, and I've worked with SO and BHP. I've been offshore Bass Strait and worked in oil refineries and things, so that's the sort of thing I used to do. But then at some point I became a bit aware of the climate emergency. And this photo represents 3 places where I used to live or work or play. So Seaside Heights, New Jersey, destroyed with the superstorm Sandy. I used to live in New Jersey. Cameron, Louisiana, wiped out by Hurricane Rita. BHP used to have an offshore operations base at Cameron, Louisiana. That got destroyed. And of course we all know about Marysville and the Black Saturday fires. So we'll get back to air conditioners, but that's just a bit of a reminder as to why it's also important to be thinking about the footprint of the things that we're doing. Okay. Here are the big 4 in Australian renewable energy. Hydroelectricity, like the Snowy scheme, wind, rooftop solar, and air conditioners. Air conditioners? What the heck? I thought air conditioners were bad. They use electricity in the summer. They're expensive to run. They strain the electricity grid. They're environmentally unfriendly. Air conditioners are the devil. Please explain. And how can you generate energy, or how does an air conditioner use renewable energy anyway? Well, all those nasty things about air conditioners are true in the summer, of course. So if you're running your air conditioner a lot in the summer because your house is not a very good thermal performer, then you can run up a big electricity bill. It does strain the electricity grid. It does do all those things when you're using it in the summer. But in the wintertime mode, which is what we're here today to talk about because we're very close to the beginning of winter, is that when you run your air conditioner on reverse cycle mode, should you be able to do that, is that you might find they are the cheapest way to heat your house. You might find that it's far cheaper to use your reverse cycle air conditioner to heat your house than to use gas. So we're encouraging people to go home and find the heat button on their remote. A lot of people don't know they've got a heat button on their air conditioner's remote control. So go home and see if you can find that and turn it on and see what happens. But let me explain how this all works in the economics. First of all, probably need to stop talking about them as air conditioners and really talk about them as heat pumps, because that's what they are in the wintertime. In the 1970s, we had heat pumps in America, so it's not a new technology, although the efficiencies have improved remarkably over time. So here we just see some recent quotes I've pulled out of overseas, because everywhere else in the world they call them heat pumps. In America they call them heat pumps. In the UK they call them heat pumps. In New Zealand they call them heat pumps. In Tasmania they call them heat pumps. But in mainland Australia we call them reverse cycle air conditioners. I like this one from New Zealand where they spent $129,000 to refurbish the toilet block and to replace the coal boiler system with a heat pump. Now, I don't know how much they spent on the toilet block and how much they spent on the coal boiler. Here's how a heat pump works. This is a discussion group, maybe a bit more technical than some audiences, so we could go through it. And of course there are the 4 major pieces of equipment that you have in a refrigerant cycle, because basically a heat pump is just a refrigerator. You've got your compressor, you've got your 2 heat exchangers, and you've got your expansion valve. And so the refrigerant goes around and round and round, driven by the compressor from hot to cold to hot to cold. And basically a refrigerant cycle, a heat pump like that, shifts heat. It doesn't so much generate heat as it shifts it from one place to another. And so we've got heat pumps all around us in the form of refrigerators. Refrigerators shift heat. They shift heat out of your food into your kitchen. Your kitchen might be 30 degrees on a summer day, but somehow it is able to shift heat out of the fridge, even though the fridge might be 4 degrees. Your freezer is even colder. It shifts the heat out of the fridge into your kitchen by using the refrigerant cycle. Same thing occurs in the summertime when we're using an air conditioner. We shift heat from the lounge room outside. And so if you go outside in the summertime around this thing, it'll be hot. And you can basically feel the heat that's being shifted from your lounge room and being rejected outside. Even if your lounge room is 25 degrees and outside is 45, this thing still operates and it shifts heat from the lounge room outside. Now some bright Spartan looked at this one day and said, I wonder if we can turn this around and get it to work the other way. During the wintertime, instead of shifting heat from here to here, then we shift heat from here to here. And that's the reverse cycle air conditioner, shown here. So what it does now, when you turn it around the other way, is it's able to capture free, renewable ambient heat, basically another form of solar energy, because the air outside is warm only because of the sun. And so it's able to grab that heat, pump it up to the temperatures you need with the refrigerant cycle, and bring it inside. So these things work down to 0 degrees, down to minus 10 degrees. That's the heat pump for heating the home. And they can also be used to heat hot water. So some of you may have already purchased one of these. So this is a heat pump for hot water. There's already 200,000 of these in Australia. And I know that because you can get renewable energy certificates when you buy a heat pump for hot water. And so I can go to the renewable energy database and see that there's 200,000 hot water heat pumps have already been purchased in Australia. I was up skiing at Mount Buller. Well, actually, we're down in the motel at Mansfield, and it was about minus 2 degrees outside before we went skiing. Had a hot shower inside the motel, walked outside. And where did my hot water come from? They had about 8 of these lined up at the motel at Mansfield. So they made an economic decision. They were going to provide hot water in the middle of the winter to their customers, not using LPG, not using mains gas, not using wood. Rather, they would just use heat pumps and capture the renewable energy. And also these things can be done at a very large scale for industrial purposes. So for providing heat for dairies, for food processing, there are limits as to the temperatures that they can get to. They can't get to 1,000 degrees, but you can use heat pumps for a lot of those low-level energy applications. And but now what about the part for renewable energy? To stress that again, so on this unit, the hot water system, you do have to buy 1 part of electricity, but with that 1 part of electricity, you get 4.5 parts of hot water. How did that happen? Well, it was able to capture 3.5 parts of renewable ambient heat from the air outside this unit and to put that into your hot water. So these things, since they're always in heating mode, they don't run in reverse, unless you want to make ice, I suppose, but they don't run set up that way. But these units, if you go near them when they're operating, it is always cold around this unit because it's sucking heat out of the air and putting that in your hot water tank. Same thing for the space heating. So here we have a reverse cycle air conditioner. This is a very efficient one. You buy 1 part of electricity and you get 6 parts of heat coming into the house. It's basically 600% efficient. If you buy 1 part of gas and try to heat your house with it, why its efficiency will be less than 100% because you burn the gas, some of the heat goes up the chimney and so forth. So this can be more than 100% efficient. In fact, it can be 600% efficient. And this is the amazing factor that shifts the economics and means that heat pumps can beat gas in terms of home heating economics. So you buy 1 part of electricity, get 5 free units of renewable heat, it goes in there. In the UK, you do get renewable energy certificates for buying a reverse cycle air conditioner or heat pump. In Australia, you don't. At Melbourne Uni, we really based our work on work that had already been done by the ATA, the Alternative Technology Association, and then we commissioned them to do a bit more modeling because they already had all the models set up. And but we were the first ones to look at ABS data and work out that, we all love rooftop solar. Rooftop solar is fantastic. Everybody's out there putting up solar panels on the roof. And they generated this much energy in 2014. All those rooftop solar panels generated that much energy in 2014. We worked out that we think that people using their reverse cycle air conditioners for space heating generated or recovered that much renewable energy from the heat pumps. So when people are looking for what's a big source of renewable energy for Australia, you should not overlook the heat that's in the air and that can be recovered with the heat pumps. It's bigger than rooftop PV. The amount of energy that we recover with rooftop solar can grow as people put more and more panels on, but the amount of energy that we recover with heat pumps can grow too, because most people in Victoria and Canberra don't realize that the reverse cycle air conditioner that they bought last summer to keep their house cold is actually the cheapest way to stay warm in the winter. And so we expect to see a lot more use of reverse cycle air conditioners for heating throughout Australia, particularly Victorian and Canberra, other places that haven't cottoned on just yet. I mean, this is already happening in Queensland and South Australia and New South Wales to a large extent, and Tasmania. Tasmania is all over it. They've had heat pumps for years because they've been largely electricity driven down in Tasmania since the beginning, and only recently have had a gas connection. So people have been heating their homes with reverse cycle air conditioners, heat pumps in Tasmania for a long time. So it's really Victoria, Canberra that need to catch on. But I do want to make a statement that, you can't confuse these type of heaters with these type of heaters. These are electric heaters. In my mind, this is not an electric heater. This is a renewable ambient heat collector. Yes, you do need to buy a bit of electricity to drive this, but you also need to buy a bit of electricity to run your ducted gas system. So is a ducted gas system an electric heating system because you buy a bit of electricity to run the blower? No. Is this an electric heating system because you buy a bit of electricity to run the compressor? Not in my mind. It'd be more sensible if we referred to these as renewable ambient. These are electric heaters. These can't be more than 100% efficient because they're not stealing any free renewable energy from anywhere. So these can be 100% efficient, which sounds great, until you realize these can be 600% efficient. With the latest and greatest reverse cycle air conditioners, first of all, they've really worked on the efficiency. In the old days, you could buy an O-star or a 1-star or a 2-star unit, but these days you can buy a 5-star unit, a 6-star unit, you can buy a 7-star unit. And if you want to go home tonight and look at this air conditioner that you've never used for heating, and you're wondering how efficient it is, the key word will be this word inverter. So it's when they came out with this inverter technology that efficiency improved quite a lot with the reverse cycle air conditioners. And inverter means, I'm not an electronics or electrical guy, but inverter means that, in the old days when you had an air conditioner, it was kind of off or on. It would come on, it would go boom, and the lights would dim in your house and probably on the whole street. But these days with the inverter technology, it's able to modulate more like, gas pedal on a car and work out how it thinks it should be operating in an efficient way. So they use the inverter technology, and you always see it. They like to sell inverters. The thing you'll see Panasonic inverter, Mitsubishi inverter, Daikin inverter. So that's one thing on efficiency, but there's all sorts of bells and whistles. The amount of air filtering that you can get with these things, asthma approved, all sorts of air filtration to really improve the air quality. And then lastly, of course, you can do dehumidification with an air conditioner, but one particular unit, this Daikin unit, can actually add humidity to the air because it's, in addition to buying an air conditioner, you get a desiccant wheel, which sits on top of the air conditioner, and it can actually take humidity from the outside air tonight and bring it into your home. So a lot of people don't like the dry air with heating systems, whether that's gas or using heat pumps. And so, they've thought about all these problems that people don't like, and they're like, how do we make the air nicer for people? Okay, we'll put a desiccant wheel on. And so now, rather than hot, dry air, it's more like a trip to Queensland when you turn it on. You get the humidity happening. And some people don't like the air blowing on them, so they've looked at the fluid dynamics of the Coanda effect, and they've done all these different things to try to eliminate every single problem that people honestly have had over the years with using heat pumps for heating. What's that say? 58 million sold globally, heat pumps. So it's not like it's a new thing. And they do work when it gets cold. So they work in Canada. They're no good if they get covered with snow because you do need to keep the air circulating. It needs to capture heat from the air. And so the air needs to circulate. And so if you're looking at getting a bunch of snow, then you do a little bit of a roof over top of it like they do in Canada. My air conditioner is rated to -20, so that gives you an idea. I was at a caravan park again skiing in New South Wales. So I was at a caravan park in Jindabyne. And so we went outside, and there, why were we staying warm in the caravan? Well, they had a heat pump outside, and it was fair dinkum, it was -9 degrees in the car park, and the heat pump was working just fine. So it must also be rated to 20 below. If you're in Jindabyne, you buy an air conditioner that's rated to 20 below. Okay, so that's the renewable energy story. Heat pumps can recover up to 5 parts of renewable ambient heat, but you do have to buy that one part of electricity. And what if that comes from brown coal in Victoria? Well, if you don't want to buy or use brown coal electricity, then of course you can buy 100% green power, which then will cost you an extra 6 cents a kilowatt hour. Possibly you could be using your own solar energy for driving your own heat pump. But yeah, there is that component of the operation. But same with gas. You may find on a ducted gas heating system that there's a blower that uses 300 watts, so that's a fair bit of energy used just for a blower for a gas heating system. Give me 300 watts in my heat pump, buddy, and I can produce a lot of heat. So. All right, now I want to say a few words about gas. So the whole idea of is gas a good thing or is gas a bad thing? Is gas an economic thing or not? One needs to think about the environmental issues associated with gas? Yeah, a lot of folks have concerns with coal, and so they think, well, maybe gas is greener, I'll try gas. But the problem with gas is if you leak more than about 3% of the gas, from the beginning to the end, from the beginning of where you get it out of the ground, process it, put it in pipelines, distribute it to the community, and it's used in people's houses, if you leak more than 3%, because methane is such a powerful greenhouse gas, nearly 100 times more powerful than carbon dioxide on a 20-year basis, that you'll be worse than coal. So the gas and oil companies really need to be careful that they're not leaking much gas, and the gas distributors need to be careful they're not leaking much gas. But one of the things that's happening is there's technologies becoming available where it's easier to detect gas leaks, methane leaks. Methane is a colorless, odorless gas, so it can just disappear into the atmosphere. It's lighter than air, doesn't even necessarily cause a fire hazard because it rises and disperses so quickly. And so you can just leak it and nobody really notices or cares. But there are technologies, infrared sort of detecting technologies available now for looking at gas. And so someone drove around the streets of Boston, and so this identified something like 3,800 leaks in the Boston gas system. So that's the gas just leaking off to the atmosphere and contributing to the greenhouse problem. Our street in Sandringham, you used to be able to smell gas all the time. Okay, they recently came and put the plastic pipes in rather than the corroded metal ones to try and get on top of that. Methane is going up in the atmosphere, the concentration of methane. We focus a lot on carbon dioxide. Carbon dioxide went over 400 parts per million down at Cape Grim, Tasmania recently. But methane likewise is going up. Partly due to agriculture, partly due to methane out of coal mines, but also partly due to methane that's being lost by the oil and gas industry. So methane's out of control in the atmosphere. This was a big leak in California. So again, this would be invisible to the naked eye, but this was a gas storage facility. So under the ground there was probably the right type of rocks that held gas or oil in the past. And once that oil and gas was taken out the first time, you can reuse that reservoir to store gas. And so that's what they've been doing for some period of time. But then they had a well blowout and out of control. And so there's a big methane leak in California. Now this would have been invisible to the naked eye, but with a special camera using infrared, you can make an image out of it. And so this is what it would look like under infrared. This was a very large leak in California, went on for 100 days before they could do some extra drilling and shut the well off. And there's a chance that, California is kind of known for doing some good climate response things, more renewable energy, all that. There's a chance that this one gas leak has wiped out all the good things that California's done with respect to climate change so far. Unfortunate. People had to evacuate. There was thousands of people had to evacuate their homes because in addition to the colorless, odorless methane, there were also some other contaminants like sulfur compounds there, and people were getting ill and had to be evacuated. So the company there is up for billions of dollars of all sorts of claims. And now these days we've got the unconventional gas. So in the old days, it used to be pretty easy. You'd get out of the Bass Strait, and relatively easy. You'd get out of the Bass Strait and you'd be looking for oil, and you'd find there was some gas with it, and so there was a bit of a byproduct. You produced the oil. The government didn't let you just flare or release the gas from the Bass Strait, so that was a good decision a long time ago by the stakeholders. And so that gas was saved, and so now we're still using it today for industry and for homes in Victoria. So it used to be, as I say, a relatively easy thing from the point of view that you could drill one well in the Bass Strait, and you could take a handful of wells, and that could run Melbourne at night, on a winter's night. Just 24 wells could keep Melbourne going on a winter's night. But these days, what the industry's on about is this unconventional gas production, oil and gas production, and that involves these close spacing of wells on the surface, and then involves horizontal drilling, and it can involve the hydraulic fracturing, where you fracture the shale and the coal seams underneath in order to be able to recover oil and gas from places that they couldn't get it before, and that you certainly couldn't get much of it with just one or two wells. But it's been worked out how to do the hydraulic drilling and how to do the horizontal drilling and the hydraulic fracturing, and to actually get oil and gas out of shales and coal seams that previously weren't productive. So this is what you see going on in America. But there's also been a lot of methane research done in America recently. Umpteen papers published. And one of the things that folks in America did is they looked at satellite data going back some time, and they found this one particular hotspot of methane in the US using the satellite data. And it just so happens that hotspot is over the world's largest coal seam gas operation in that area of America. Of course, the unconventional gas is going on in Queensland as well, and so this is what you see in terms of the amount of wells needed to produce gas from the coal seams in Queensland. Another thing that occurs is that you may want to, so stuff comes out of the ground, it's gas, it's water, it's oil, and you need to separate it. And you might not have the infrastructure or the interest in recovering all of the gas, and so you might just let it disappear into the atmosphere, and that's called weathering off, if you want to weather off some oil you've taken out of the ground. And so again, using special infrared cameras, you can detect now the gas that's being released from this storage tank in America. So that's some of the issues with gas, and so that's why it's really interesting to see if there's other ways that we can heat our homes. And if it turns out that it's actually cheaper to do that, well, then it becomes really hard to come up with reasons to use gas in your home. And like I'm saying, when you use gas in your home, you may, you might operate your whole gas heating system with an efficiency of only 50%. You burn it, a lot of the heat goes up the chimney to begin with. So we're kind of, in my view, we're kind of wasting that gas, particularly if there's other ways to heat your home. If industry is interested in using gas, well, if we used or wasted less in our homes, then that would make more available for industry. The price of gas is going up because now it didn't used to be possible to export gas from Eastern Australia to overseas customers. They would liquefy gas in Western Australia and the Northern Territory and put that on boats and send that to overseas customers. That's been going on for quite some time, but it was never done in Eastern Australia. It was the sort of thing that Esso and BHP would look at from time to time, but it was never economic to do so. But with the coal seam gas up in Queensland, it was found that was the way to make money out of that, or attempt to make money, was to build a facility. So like $60 billion worth of gas plants have been built in Gladstone, Queensland, to liquefy gas so it can be put on boats and sent to overseas customers. So that is now occurring. Gas is now flowing. Gas is now flowing on this map here all the way from Victoria through New South Wales up to Queensland, up to Gladstone, where gas, even from Bass Strait, is being liquefied, put on boats, and sent to overseas customers. So what this means is the whole market has gone from being a bit of, gee, we got this waste byproduct, how can we give it away? To now, gee, here's this valuable thing we can sell overseas. In fact, we've got to meet contracts. So that's kind of driven up the price of gas on the wholesale market, and will continue to do so. So again, that helps the economics for heat pumps. This is an article that was actually up in the Age when we released our research, which was at the end of last winter. And unfortunately, it was the end of last winter, and so that's why I decided I should get out talking to people at the beginning of this winter. They'd be more interested. But even back then, the Age ran this article and picked up the one number that an average large Melbourne home could potentially save $658 a year by using reverse cycle air conditioners for heating their home. Reverse cycle air conditioners they may well already have in their house. So what has changed in the economics is that now we have these very efficient air conditioners, the price of gas is going up, and you can find some cheap electricity deals. So when you add all those things up, it's making a bit of a no-brainer in a number of cases to heat your house with a heat pump. And some people even have 6 air conditioners in a house that they're all using for heating right now, not necessarily unusual. And even the Grattan Institute picked up on this message. The prize is very large in Victoria, and we presented to the state government and other stakeholders about this. There's probably about 500,000 Victorian homes, this is an estimate, that have reverse cycle air conditioning but have never used them for heating. So I guess I could ask the audience here, who's got a reverse cycle air conditioner but has never really used it much for heating? Anyone? Just one? So you're one of that 500,000. And so if these Victorians were to learn that it was cheaper to use the heat pumps, the potential savings there is about $250 million a year. So this is like the biggest consumer win ever. But it does depend. So I've been in about 400 homes in Victoria helping people to save energy, improve the comfort of their home, reduce their footprint. And I can't stand here if someone asks a question and guarantee, yes, it will be cheaper for you to use your heat pump. Because it depends. It depends on four things. What do you pay for gas? What do you pay for electricity? How efficient or otherwise is your reverse cycle air conditioner? And how efficient is your gas heating system? But you can multiply those four numbers together. And I probably shouldn't have done this in this presentation, but I've done it on the board there, and you can work out which is cheaper. So, what do you pay for gas? Gas prices vary, so have a look at your bill. First off, ring up your gas supplier and get the maximum discounts. There's discounts of 25% available now. People say, how do I get them? I say, you ring up, you threaten to switch, you do whatever, you get the 25% discount. And you'll find on your gas bill there's different blocks. They'll charge you less if you use more. So the more gas you use, the cheaper the blocks of gas become. So it's a little bit complicated on your bill. You can work it out, and it might range from 1.3 cents per megajoule to 2.2 cents per megajoule. And golly gee, in Canberra, this can get up to 3.8 cents per megajoule. So they pay heaps for gas in Canberra, and folks there really need to start turning on their air conditioners. But anyway, so that's how to work out how much you're paying for gas. Electricity has an even broader range of prices. If you're not getting any discounts, you might pay 38 cents per kilowatt hour at home right now, because this is peak time, if you're on a peak off-peak plan. Again, get the discounts. There are discounts of 34% available, particularly from PowerShop, but from AGL and others you can get 30% discounts on your electricity, so make sure you get your discounts. But I've been in a lot of people's homes where they're getting no discounts. They don't know. The state government is a bit disgusted with it, but that's the market that we live in here. So get the discounts, but you could be paying that much for electricity, or you could be paying as little as 5 cents. If you've got your own solar system, and you're not getting paid much for putting it out onto the grid anymore because you've got a low feed-in tariff, you might be getting only 5 cents a kilowatt hour. So why would you basically give that electricity away for 5 cents a kilowatt hour when maybe you could use it in your own home with a heat pump to heat your house and stay warm? So this is a broad range of electricity prices to be considered, and it's even a little bit broader. I've got solar panels at home, but on a good feed-in tariff is 66 cents. So I don't heat my home with my air conditioner when the sun's out, because it would be costing me 66 cents to run my air conditioner. Unfortunately, our home has northern exposure and double-glazed windows and stuff. We don't actually need to turn the heat on when the sun's out. But there's the whole range of economics that you could think about if you really want to work it out in great detail. And then how effective is your reverse cycle air conditioner? If you've got an old 15-year-old unit, it might only be 200% efficient. So it might have no stars. But these days you can get a 7-star unit that's up to like 600% efficient. So again, a broad range there of possibilities. And then this is one way you can work out the efficiency of your air conditioner if you've lost all the paperwork or you bought the house and someone else installed it. This shows you an input in kilowatts and a heating output in kilowatts. So this unit will use about a kilowatt and give you 4 kilowatts of heating. So you can see that 400% efficiency right there. Now the gas systems also have a star rating. But this is something that's managed by the gas industry. The government's not actually involved with that. But if you are in the market for a gas appliance, we'll certainly get one with a very high star rating. But when you think about ducted gas systems, which a lot of Victorians have, the efficiency of those could be less than 40%. And this is a message that Beyond Zero Emissions has been talking about for a real long time. Richard teaches a lot of the work. And so ducted gas systems can be very inefficient. You burn the gas, a lot of heat goes up the chimney, but then the gas has to, the warmed air, it comes into the ducts. And this shows a infrared thermal image and a visual image of some ducts under a client's house. And here we found that the ducts were just split. And so they were just having gas come out underneath, warm air come out underneath the house. And it turns out that this has probably been going on for 20 years. So for 20 years, that's been the efficiency of their gas system. So if you've got a system like mine, ducted heating in our house is 20 years old. The house is really low to the ground. The dog's been under the house. The electrician's been under the house. Lots of things have been under the house, and I don't really know the conditions of the ducts. They're not really inspectable unless I do some excavations. We did do a renovation one time, and we found some holes in the duct. So I might judge that the efficiency of my particular unit is not that high, but it's probably not a lot different than a lot of other people's ducted systems. So we could create a spreadsheet here and we could multiply these numbers together. And I reckon that somebody needs to build the heat chelator and load it up to a website, but that hasn't occurred yet. But it would be handy to be able to offer to consumers a way to analyze the situation. The Victorian government's had a stab at it. So if you Google what's the cheapest way for me to heat my house, you get this sort of information from the Victorian government, and they're trying to, there's a whole bunch of different options. And this doesn't even talk about the differences in efficiencies of different units that you can buy, and it doesn't talk about different gas and electricity prices. So the government's had a bit of a stab at it, but it's what they've got here on the websites is way out of date. We've met with Sustainability Victoria about it, and they don't even have the budget to pull this down. So here's invalid, out-of-date information for consumers, and it's also oversimplified, unfortunately. And they actually have 2 pages where you can go to. They give you different answers. So that's the state of the situation with the Victorian government's information. Now this is just something. Some of you might have seen a lot of this before that I'm presenting tonight, so I wanted to come up with something new. And I actually saw from a New Zealand website a way of trying to describe heating costs with this range of the bar chart. And so I've just got a range of different gas prices and electricity prices and efficiencies here on this bar chart. And so like if you've got an electric resistive unit, your cost for heat in dollars per kilowatt hour, but that doesn't matter what the numbers are. It's a broad range. If it's off-peak electricity and it's pretty cheap electricity, your cost for heating might be this low, but they could be this high. And so this is a message here that stay away from electric resistive heating if you possibly can, and use some of the other systems. Unless this is a little heater that you stuck under your desk because all you want to heat is your legs underneath your desk and you're not trying to heat up the whole house with it. But I've been in people's houses, sometimes tenants, renters, and they're trying to heat up their whole house with electric resistive heating, and so they may be paying costs up like this. Gas ducted units, a broad range depending on what gas price you assume. I think this is just Victorian prices. If I put Canberra prices, then you have a chance of having gas costs out here. A gas wall unit can be more efficient than a gas ducted system, so maybe there's a range like that. And then there's heat pumps, and I've put some efficient and inefficient ones there. But you can see, I do have a 7-star air heat pump, which is very efficient, and I've got a good deal on electricity from Power Shop. And so, say like on a weekend, I could be paying this for my heating, something like that. 0.02, I think it is on my spreadsheet. That's how cheap the heating is in my house. We'll run our air conditioner for an hour to heat up the house, and because the Sorara even tells you how much electricity is used since you turn it on. I looked at it and I said to my house and my wife, we heated the house for 20 cents. But there is a range, and so this is the challenge, trying to express to consumers, what's the answer for you? Is it here, comparing with this, or this? And so you can, you're comparing that with this, and obviously electricity for the heat pump is a big winner. But if you're comparing that with that, well then maybe gas is most economic. This is the calculation, pretty simple of course. A gas price and electricity price. The gas is in terms of megajoules, so you got to convert that to kilowatt hour. You stick in whatever efficiencies you think you've got, and you might come up with something like this. And in this particular example, the gas heater is 1.5 times as expensive as the heat pump. And the big factors you see is, should multiply that by that, but you'll find that on an energy basis, gas is traditionally cheaper than electricity, but it's this factor of 4 or 5 on efficiency that brings the heat pump into the picture. I had to play around with this, and if any of you went to uni before there were calculators or computers, you'd recognize a nomograph. I think that's what it's called. And this uses logarithms, like you have on a slide rule. But it's actually kind of handy. What you do is you line up. So the red line's electric, so you pick an electricity price, and you pick an efficiency, and you draw a line. And for the gas, which is the blue line, you pick a gas price, and you pick an efficiency, and you draw a line. Whichever one is lower is the winner. So in this particular example. And so this can be a bit handy because it shows that the heat pump is going to win, even if you get up to only 200% efficient. So like if it's a 0-star unit, it can still win. Shows you maybe how that works visually. But this is too hard for a lot of consumers. So what we also have tried to come up with here are just some case studies. And so we've got a few case studies in this presentation, and this is uploaded on the internet, so you don't have to read it all here. But the hope is that some consumers might be able to read through these case studies and say, yeah, that house sounds like mine. I think I'll try my heat pump. This is the case study of Gasless Gale. Gasless Gale already had a electric cooktop, and she had gone out and had bought a heat pump hot water heater, and she was asking me why she still had a gas bill. And I said, well, you're using a little bit of gas for your pilot light on your gas heating system. And it was summertime, so she said, can we shut that off? And I said, yeah, you can shut that off. You got to relight it later. So she said, shut that off. She said, right now I won't get a gas bill. I'm like, well, yeah, you'll still get a gas bill. You got to ring up the gas company and tell them you don't want a service anymore. And I said, but are you sure you want to do that? So it turns out she had a ducted reverse cycle air conditioner system. She had used it for cooling. She hadn't found the heat button at that point on her remote control. But she was happy to give it a go. And she said, no, I want to get rid of gas. So let's just shut that off. She rang up the gas company, no more gas bill, and the next winter she found the heat button, and it's working quite well for her. She's probably got like a 1-star unit, but we've compared her electricity bills since and her gas bills before, and I reckon she's saving, it's not a big house, she's saving a couple $100. Eventually her 16-year-old aircon will die, and she'd probably save a bit more when she improves the efficiency of it. A few more case studies here. And then this is our own home, where in an old, 100-some-year-old weatherboard house, doesn't cost a lot to heat to begin with because we got the insulation, the double-glazed windows. So probably it used to cost like $500 a year for the gas energy. I'm not talking about the gas fixed charges, but just the gas energy, about $500 a year. And we put air conditioners in either end, one in the bedroom, one in the lounge room, mostly for cooling, so we could sleep or watch the tennis in January. But then last winter I started doing trials with the air conditioners, and so instead of spending $500 on energy to heat the house, I think we'll be able to heat the house. Well, no, we worked out last winter. We were able to heat the house with these air conditioners for $150. We're heating a whole home for $150, whereas I've been in homes that are spending thousands of dollars for energy to stay warm. This is the first time that this has been presented, and what this graph is showing. If you're below 1, you're onto a good thing with this comparison of heat pump versus gas heating. So I should change that to heat pump versus gas heating. And these days, with an efficient heat pump and the situation with current gas and electricity prices, you can be well below 1. And so this is basically why I'm saying that my house will cost a third for the energy cost of what it used to. But it made me think, well, this is the situation now. How long has it been this way? I've only been in this business recently. I used to do other things. BZE was onto this and calculating things quite some time ago. But I said, how long has it been this way? And it turns out, well, certainly the efficiency of air conditioners has improved with time. This is a very efficient one. 5.8 coefficient of performance. These are less efficient units. Probably back in 2007, this was all you could buy. And even then, it wasn't much worse than gas. But then electricity prices did shoot up, 2010 or whatever, and still people weren't thinking about it. But now electricity prices have come down again in Victoria. You can get some good deals. Meanwhile, the price of gas has gone up, and the efficiencies have improved so remarkably. So now this is why you can be on to such a winner these days with heat pumps in Victoria. There's a few references available. One you might win as part of the raffle. This is mostly Richard Keach's. Well, part of this is Richard Keach's story of his house, which is gas-free. But also it's the whole beyond zero energy freedom approach of the 9 steps that you can take to get your home off of gas and operating a lot more efficiently. Also the ATA has published things such as the Green Home Heating Handbook. And the ATA's got a couple of different brochures which I spread out on the seats as well that you might have collected, which are discussing this message. There's Richard's family. So this is how to make your home completely gas-free. If you can get in the situation that you're comfortable with your heat pumps for heating your spaces, heat pump for hot water heating, induction cooktop for cooking, then you don't need gas anymore. And in fact, that was what the work by the ATA found, that there is no economic reason for any new house in anywhere in Australia to be connected to the gas grid in terms of economics. There's no economic reason for any new suburb in Australia to be connected to the gas grid. And in terms of existing houses, well, up in New South Wales, there are hundreds of people that are leaving the gas network in New South Wales. I was at a gas conference back in March, and Gemina, who distributes the gas up there, was talking about the customers that they're losing from the gas grid up there. People talk about coming off the electricity grid. Oh, I hate electricity companies. I'm going to buy batteries, solar. I want to come off the electricity grid. People are talking about coming off the electricity grid, but few are doing it. People aren't talking so much about coming off the gas grid, but people are doing it. And back in January, AGL raised the fixed charges. So we still have gas to our house. And AGL raised the fixed charges by 25% in January. So that's the daily charges. And I went back in time, and they've raised the fixed charges 75% in 5 years. So AGL down here is basically chasing people off the gas grid. And so you can now spend almost $1 a day just be connected to gas. So that's up to $300 and some dollars a year that you could be saving if you didn't have the gas. And that particularly is probably true in some apartments and things where all they have gas for is for cooking. So why wouldn't you get an induction cooktop? One last in the presentation, it talks about evaporative cooling as well. People say, well, if I'm going to get a cooling system, should I get refrigerative, reverse cycle, or should I get evaporative cooling system? I say, well, evaporative cooling, with that, you can't heat your house. So if you get a refrigerative reverse cycle air conditioner to cool your house, you get a free heater for the wintertime. References. Maybe you'll never think about an air conditioner the same way. That's it. Open to discussion.
We'll get questions going. I had one to start with, Tim. Regarding the rating where you said negative 20 degrees Celsius, does that do anything for the performance of the unit? If it's colder outside, is it going to be harder for it to heat a space inside than if it's 20 degrees outside?
Right. So a heat pump. The thing about a heat pump is what it does is it pumps heat. And so it's kind of like pumping water in a sense. I mean, if you go pump water this far uphill, then the pump has to work hard. If you only have to pump that far uphill, the water pump doesn't have to work as hard. Same thing with an air conditioner or a heat pump for heating your house. And again, when the government produces these star ratings, they do it at like a standard temperature, I think, of outside temperature of 7 degrees. But say it's 15 degrees outside. It's a bit chilly, and so you want to turn on your heat pump to warm your house up just a little bit. It doesn't have to do much work, and so the efficiency there is going to be pretty high. So again, I say to folks, if you're not totally sold on this idea, well, at least try your heat pump in the autumn and in the spring, and certainly when it's not that cold outside, but you want to heat the house up a little bit, you don't need to turn on the whole gas system, possibly, depending on where your air conditioners are. And it can work very efficiently because it doesn't have to pump that hard. It's only pumping a few degrees. Yes, as Melbourne gets down to 0 degrees, then it will have to work harder under those conditions.
What's the feasibility of converting an old ducted heating system, gas ducted heating system, use a reverse cycle air conditioner, but use your old ductwork?
Yeah. There's umpteen combinations. What I've got at home is just a split system air conditioner, a couple of them. So you got your indoor unit and right outside the outdoor unit. And it's just connected by small diameter copper piping, which is just a refrigerant going around. But there are plenty of houses where they'll have a heat pump for cooling and heating, reverse cycle air conditioner for cooling and heating, but they will distribute the hot air or cold air with ducts in the ceiling. So that's quite commonly done too. So yes, if you had some ducts, you could buy a system that potentially could use those ducts. Your air conditioning experts would probably come around and say the ducts are the wrong size for some reason. No doubt, that's Murphy. But whether you're trying to do cooling or heating, you might need different size ducts or what have you. But all those different systems exist, and so it's a possibility.
I think
and also,
ducts for,
what's that?
I think maybe ducts for cooling or something.
Yeah, quite possibly for a certain amount of cooling, but maybe you could be happy with less cooling. But I'd say make sure your ducts are in good shape. And if you do want to buy ducts, you can buy different sorts of ducts. Some that are better insulated than others, some that are structurally stronger than others and can withstand small children and dogs and things like that. So if you're in building a new property or do want to get some ducts for one reason or another, get some good ones. There's good ones and bad ones on the market. And you potentially could do a retrofit like that. Another retrofit people are talking about is they might have a hydronic system, a gas hydronic system. So that's hot water going around the house through the radiators. Yes, you can run that off of a heat pump. So if you did want to use gas to heat that water, you would just use a system very similar to that hot water heater I showed before that's a heat pump, and quite happily run a hydronic system with a heat pump. And that's part of the problem, but one of the interesting things, I've been in so many houses, but they're all different, and there's just dozens and dozens of different types of heating systems that are employed in all of them.
Can you tell me what size the two units you put in either end of your house are?
Get on the Facebook group. So I don't know if you were here at the very beginning, but if you're on Facebook, join our Facebook group. If you've got some floor plans or you're in the market or you want to know what can be done. Also, I also published our whole case study in Renew magazine. So in Renew magazine issue 133, there's our whole story, and the ATA has added a few extra bits to complete the whole story about outlining all these things. But that particular top-of-the-line 7-star unit from David, which is called the Aruba Sorara, that's the name for this discussion group, although we talk about everything. That particular unit is available in 2.5 kilowatt and 3.5 kilowatt cooling. And we were in the market for some cooling for our house. We've done the renovations, but so we need some air conditioner, one in the bedroom, one in the TV room, so you can watch the tennis. And so I had the guys out to give me a quote, and they wanted to sell me like 12 kilowatts. We ended up buying 6 and completely happy with that. So that's one message is avoid the upsell for folks that come around your house to sell you air conditioners. It may not even cost that much to get one that's a lot bigger than you need. And if you hardly use it, you hardly ever use it full blast, well then it can actually work very efficiently. So you spend some extra money and you may get some even better efficiency because it's hardly needed in a house. But the air conditioner folks do tend to prescribe more than you're likely to need because that way you'll be happy you're never going to ring off and say it wasn't big enough. So fair enough for that. But that's one of the things that we can try and do with this discussion group is for people who are interested in trying to keep you a little closer to the line or work out, what's the minimum they need for their house. You can discuss things with other neighbors on social media.
I noticed that the units, these air conditioning units, are often very high. Is that just aesthetics and being able to use? Could they be lower for heating and cooling?
Yeah, in New Zealand you'll find them more low. And it comes down to whether you use them more for heating or cooling. So in Australia, traditionally we wanted them more for cooling.
Yes,
but what I'm saying is for Victoria, actually, we do want them more for heating.
Yeah.
I mean, you might heat your house, you might cool your house for a couple of weeks through summer, right? Whereas we're going to be heating our houses for 120 days or so through the winter. I think in my case, I use 10 times as much, last calendar year, I used 10 times as much energy in my air cons for heating than I did for cooling, just to give you an idea. But mine amounted up there. But you can buy ones that
Yes.
And so every house is different. You need to, one of the advantages of having it up there is everybody usually has space up there. Whereas down here, you've got a couch, or you've got a piano, or you've got a television or something. So it can be hard to find space in smaller houses around the walls, and so sticking up there is not a bad thing. But one of the things that people haven't liked about heating with air conditioners is they don't like the hot air blowing on it. Well, this Dakin, you can tell that I don't like the hot air blowing on me, and so it doesn't blow hot air on. So it's got some sort of a detector, and it can see where you're at, just while your head moves, so it knows where you're at, so it blows the air over there. And so if you move over here, it blows the air over there. So they've tried to think about what's all the bells and whistles they can provide to keep somebody in some pretty terrible apartment in Tokyo comfortable, I think. And that's now available in the Australian market.
Can you talk to single split versus multi-split and standby power?
Standby?
Standby power.
Standby power, yeah. So I said that I've got a pretty simple split system at home. It's an indoor unit and an outdoor unit connected by some copper piping. Or you can do the ducted system. That's another way to do it. And then you have air running around through the house, through the ducts. But another way to do it is to buy what's known as a multi-head. So rather than one indoor unit, one outdoor unit connected by copper piping to the refrigerator, you can actually get a number of indoor units with one big massive outdoor unit. And so they call that a multi-head. And so it can connect up individually to all these different indoor units that you have. When I looked at those, and that's in fact what the guy had recommended to me initially, was a multi-headed unit. And instead of just the two, we would have four, inside of the house. Now, when you look at the star ratings aren't as high, so you don't find a 7-star with such a high coefficient of performance multi-headed unit on the market yet. However, probably the way they score those multi-heads is to assume that all the heads are all operating all at the same time, whereas possibly in a real house that's not going to be the case, and you wouldn't really be stressing the multi-head at full power all the time, which means that like I say, they might have actually invested in a lot of extra heat exchanger area, which might improve the efficiency of it. Anything you might add to that point, Richard? Okay, and on the standby power, like any device, you got to read the fine print sometimes or do some research. But traditionally, some air conditioners, heat pumps have used standby power to keep the oil in the refrigerant system warm. And so there can be some significant standby power. The new ones with the higher star ratings don't need that standby power. But you can find, you might have a versatile air conditioner at home, which you only use for a little bit for cooling, but it's been burning standby power 365 days a year, so that's something to check out. And that was written up a bit in that ATA article I mentioned with a bit more authority, because I'm not an expert on that. But apparently you can shut off the power to your unit if you're not going to use it for a few months, but you should turn it back on a couple days beforehand, before you're thinking to use it, so that whole oil warming thing can happen. Or you might want to check with your manufacturer to make sure you're not doing something that will damage you. Any other thing on standby power?
I'd just say that I'm a fan of multi-splits because the standby power tends to go with the outdoor unit. So if it's a choice between having 4 indoor units and 4 corresponding outdoor units on one hand versus 4 indoor units and 1 outdoor unit on the other hand, the latter will give you much less standby power because it's the outdoor unit that's chewing the standby power. And having just a 1 outdoor unit generally means less visual impact.
Sure, absolutely.
One of the reasons a lot of people don't like the splits is because they don't want 5 of these things boxes sitting on their wall, and just having 1 often gives that better balance and impact.
Yeah, I think the problem is there's too much on the market that goes too little. Making decisions can be scratch your head a little bit.
2 questions. Firstly, refrigerators have traditionally had very long lives. What's the life on these modern split units? That's the first thing. And secondly, if you turn the thing off, is there any reason why you shouldn't turn it off at the mains rather than leaving it doing whatever it might do on standby.
Yeah, I guess if you thought it was okay to shut it off, yeah, you could shut it off at the mains or at the switch it might have, yeah.
Is there any reason why you shouldn't do that?
Well, it could be. Check with your manufacturer. I'm not an expert in everything to do with air conditioners. I'm just doing some of my own case study and some economics here. So, when you first start to get into the finer detail, you need to be careful that I don't cause anybody's air conditioner to have a problem. The other question was life. Yeah. In fact, I did send an email off to the person I purchased mine from and asked those sorts of questions. And it's a 5-year warranty. And I reckon it shouldn't get any trouble for 10 years, whether it goes to 20. Yeah. Again, you're exactly right. It's like a fridge. So why would it be worse than a fridge? I'm not sure. Fridges seem to just keep going. We'll probably get to all the questions at the time here.
I just noticed on that one that's coming up. 22, is it?
R22, yeah, it's the first one to have R22 in this country.
In terms of greenhouse gas, if a unit has a couple of kilos, do you know how much refrigerant it has in the greenhouse gas coefficient?
The R22 is not as bad as some.
Yeah.
It's not as good as like a propane or something, what they call the natural refrigerants.
And I was just wondering if we're comparing greenhouse gas emissions, would that factor in the escape refrigerant?
Or you could help it, leak in. In terms of proper maintenance and installation.
I'd be sceptical if when they get decommissioned that the gas gets recovered. So I'd be wondering, even if you said, okay, we'll assume that it's a 20-year lifespan and of the products that are in the market, the coefficient is, 4,000 times CO2, then how would that stack up?
Yep.
Would we be any better off?
Yeah, good question. I haven't done that calculation. In fact, my main message here tonight is not greenhouse as much as just economics. Yeah, I did go on about methane, but good point. And somebody made a comment in a presentation the other night. Yeah, they tend to just come in with a bulldozer and knock a house over and not really care that there's equipment in there that they should have decommissioned properly. But so there's the natural refrigerants, which are like propane or whatever, and you can buy units with that. The hot water unit I showed you uses carbon dioxide as its refrigerant, so that's a lower warning potential one, of course, so pretty low. And there are worse ones than R22 for greenhouse.
Yeah, just on these multi-head systems, I know with the ducted gas heating that the view is we can close down a number of ducts, maybe down to 60% of the ducted gas system. What about on the heat pumps, multi-duct tanks? Can you get it down to perhaps 20%? I'm thinking of a situation I have at home where we've got effectively a 7 kilowatt size room and then a 1.5 kilowatt small study, in which case I might want to work in a small area and not heat the whole lot.
I would think with multi-headed that you can consider them all individually zoned. So I expect they all have individual control systems.
Yeah.
And so
They all have their own return air.
Pardon?
They all have their own return air.
No, well,
Good ears get sucked back into it once and
well, sure. So like a multi-headed unit, there's one outside unit, a number of different indoor units, and all they're doing is dealing with the air in their own rooms. So there's no air ducts moving the air from room to room. And so all these things with the modern controls would be individually controllable, so you could consider it individually zoned.
So the outside compressor would be massively oversized for a very small room. It still doesn't matter.
Correct. Might actually be quite efficient.
Yeah.
But that's the beauty of the system they used with the what you call it before the inverter system, because I think the compressor is actually a variable displacement, so
That's right.
you can produce small amounts of flow if you want to.
Well, actually, there is a technical specification turn down. And so, if you're thinking of really turning it down, check out what that range is. Yeah, so they will have a minimum that you can turn down, but you probably can't turn it down to 1%. So, thinking that through would probably be a useful thing to do. Just a point on, you can close off 60% of your gas ducts.
Oh,
Not really.
Not really, but yeah.
Not really, because what happens when you do that, so say I'm going to close off that bed and close off that bed, I'll close the vents, I'll close the doors. Well, then you're overpressuring the rest of the system, and so that might lead to more leaks. If the ducts are leaky to begin with, then you might have more leaks happening. And when you shut them off in the bed, you don't completely shut them off. It's not like the valve, it's still blowing up, but you close the door. So now you're pressuring up that room a little bit because it can't get the air to return back. So now it's saying, where do I get extra air to fulfill my requirements? And so it sucks through this crack in the wall over here. So I've actually given up a bit on trying to zone out my ducted system when I use it, because when you think through all those things and where's the air actually going to go. A woman had such a system in the house the other day. She's like, oh, we always keep this. Yes, the air does come in there, but we keep that door closed. I'm like, no, leave that door open. You've got air coming out of there. And so if you keep that door closed, it's going to be fine its way out through the cracks in the window or something. So we have to think about the pressure balance and stuff. Yes,
The gentleman up there is
I think we'll get
all of
I've already done the same thing, and I've got the same date as you. And we actually found the best thing for comfort was actually, first we tried various settings, the magic eye stuff we actually end up turning off.
You just started what? You turned off?
The magic eye, the sensors where you I've actually just got it done straight across the roof, and I'm on very lowest fan setting, so it just dribble the air out. It's quiet as well, but that's what gives the best comfort. It never even know it's on, but it slowly warms the temperature up. The second thing I was going to say was in our previous house, we tried this old house with a 30-year-old ducted gas system. It was terrible. The house was very leaky as well. We had 4 old non-inverted heat pumps. We tried doing this and it was awful. They blew out, air that was never hot on full power, and then they turn off, they lost the temperature. The house would cool down. It was much less comfortable than the gas. It doesn't always work, that's all. That's the thing with old systems.
Yeah, so that's some of the resistance I run into, writing articles and publishing things, and then people trolls. Well, they're not just trolls, they're people that have bought a bad air conditioner in the past. And it didn't work for them, fair enough. And that's
this is a house with very old air conditioners.
Yes, there's a lot of bad experiences out there, so it's trying to educate people that there's a new world out there.
Just about the discussion group, the Facebook discussion group. My question is basically that given the building fabric is such an important part of making a house comfortable, does the discussion is the discussion group aimed just at air conditioners and economics of air conditioners, or is it about the whole?
Yeah, no, the whole thing, because they're all related, aren't they, really? If you can improve the thermal performance, the fabric of the house, the envelope of the house, well, then that means, you might be able to get by with smaller systems, which means now you're in the market for this, and so the whole world changes. So everything's related. I've never, for anybody that's posted anything, and there are other terms of reference for a Facebook discussion group off on the side there, but I've never knocked anybody back for anything they've posted because it's all connected.
Just a general question about the...
But we picked that name because,
I guess,
well, that's the name of that one particular air conditioner, and it has needed some collaboration to really figure out how it works because the operating manual is not that great. And formerly there was a lot of good information out there. But the topic's broader than that, but we don't mind the name because it's unique, kind of unique, and David hasn't yelled at us for using it.
By the way, the Aurora Serrano, does that been installed at Point Patterson?
Cape Patterson? Yeah, Brandon Commons, Cape Patterson, Eco Village,
just getting back to my house, was planned and built 2.5 years ago. We got a running gas running heat, but every time we dust it, our heat pump, we didn't know that much about it. It was all well, now you can't do it. Obviously, now you can do it.
Maybe not without challenges, because I've heard some people say it's offered, and now they don't offer that anymore. So I'm not saying it's not without its challenges to do. They try that today, and someone needs to give it a go.
Yeah, but just getting back to because I just installed a reverse cycle, Panasonic 7.5 kilo, and what I'm trying to do, there's a wave motion that shifts air. So that works both ways. So we've got hot heating and cooling. That's the case, isn't it? Because the hot is at the top, and with the wave motion puts the hot air coming down onto the ground, right? Down the road. That's the first thing. But secondly, which I'm thinking about, what I've said about all this piping, because I don't know. ducted heating. Why not? Their main is spending 90% of the day in one large living area. Heat that, right? Before you go to bed, why don't have a duct with an inline fan going through the bedroom and 10 minutes, 15 minutes before? I'm going to do that with a chronic heating now. We don't have a, I mean, I was told you've got to have this size and that size. I said, no, that's far too much from thinking. I'm thinking about it now, I should have been even a lot less. We could have saved another $5,000 basically. But, they can give you all these people and say, you've got to have time, you've got to make a decision. Anyway, so that's what I'm doing at the moment. Just before you go to bed, just turn the thing on, not dump it on the bed, just go to each valve, turn it on 5 minutes or but what I wanted to do is put a duct between the living area and bring the two things. We don't need one fan, we just switch it on when you want it. Or go to bed.
Well, I can't wait.
You don't even need over
I
anything.
can't wait to post your results on our Facebook group, and we'll see how it went.
Well, it's a working process.
All right.
So Stoke can make the Euro Sahara, and what about other manufacturers playing catch up, or are they equivalent? Where would it stand different?
Nobody offers yet. I mean, I was 7-star. Nobody offers this humidity with the desiccant wheel. And there's probably other differentiation there. But what I say is, if you're in the market, I mean, you can get on our Facebook group and ask people what they think. But the government has a website, energyrating.gov.au, where they list everything that's on the market for televisions, refrigerators, heat pumps. And so that gives you an idea of all what's on the market from no stars to 7 stars. So whatever you're buying, it's always good to look at energyrating.gov.au, because you might go down to Harvey Norman and they got 2-star, 3-star, anything. That's it, it's always on the Australian market. But that's not true at all. There's a broader range, and so they can do get a full picture of it. So yeah, we would just say, look at who's at the top of the list there for the better star ratings, and that's going to be taken in Mitsubishi and Panasonic and Fujitsu are the ones that I noticed the other day at the top star ratings.
Just in your house, you've got 2 units, and you're probably like our house, got a small room at the other house, step out of the shower at night and freeze to death. How do you keep that room warm?
Yeah, the showers are a problem, and so I have noticed us turning on ducted heating just to heat the bathroom. Can you believe it? But I think that the answer is one of those electric heat lamps. So I haven't gone around installing one of those yet. They use a heck of a lot of electricity very quickly, but you're going to need one just short minutes. Ideally, although I have heard of somebody like one on for a whole week.
We've got a heat pump in our bedroom, and we've got an ensuite off that bedroom. We very easily heat that up in 15 minutes when we put on the bedroom.
Yeah, we don't have Yeah, you have to get from one room to the next. Our bathroom's a bit of a dead end, and the floor is insulated.
Yeah, so the ensuite, they work with separate.
The other question is about aged people in aged large homes. The payback period is spend $25,000, say, on installation and as far as color glazing, that sort of thing. So say it's been $20,000, it'll take you 10, 15 years probably to get that back. Is there any evidence that that house, when it sells, is worth more?
I don't know that I think for a house to sell more, it would have to be something more obvious bling, like solar panels on the roof. I think double glazing may be worth it to some people, particularly if you're selling to Europeans. They might see the value in that. But otherwise, there's a lower hanging fruit at 20,000, and there's a list. I made a list the other day of 25 different things that people can do. And so there's a lower hanging fruit that builds you up to that 25,000. Double glazed windows are probably the last thing on the list. But, turning on air conditioners you already have, that doesn't cost a lot. But, the draft proofing and the insulation of the ceiling and the insulation of the floors, if you can get it there, and better window coverings inside and better shading outside, those are some of the lower hanging things that can really improve the comfort of the house and reduce the bills quite significantly. Richard, want to add something?
Yeah, the question touched on resale value. The Council of Australian Governments adopted in principle that about 7 years ago that all jurisdictions should move towards mandatory disclosure of energy performance of buildings And the only jurisdiction that's done it for homes is the ACT. And in the ACT, they've found that there has been a definite correlation between the performance of the house as declared when it's sold or let, and the price return. So there's a definite payback in terms of improved capital value.
Yeah, so I think what you're saying there is that eventually in Victoria it could be of use once people start to expect that they ought to be able to see like a star rating, and then if there was a star rating, they knew what it meant. They'd say, oh, this one's 6 star, or this one's 5 star, and then they might attribute some value. So it's kind of like a cultural thing. And I think it's been going on in the ACT for a while now. I did see those studies, and so it sounds like buyers now in the ACT expect that. And so since they expect that, then there could be some value. Whereas here at the minute in Victoria, people be scratching their heads when real estate agents wouldn't really know what you're talking about. The state government is launching a tool for assessing existing homes. I've actually tried it myself. It's a bit of an iPad. You walk around, you measure windows, and you do this, and it comes up with a star rating, which is different than a star rating if it's a new home. But that's, this current government is keen on that sort of thing, and it's not like it's necessarily going to be mandatory anytime in the next 150,000 years, but it's a step along that way that you might have some sort of standardized tool, maybe similar to what they use in the ACT, to judge a house. And I use that tool in a whole bunch of different houses, and gee, you got some surprising results. A lot of people are unhappy with their star ratings.
Just on that thing about mainly this big Stanford paper, UCLA paper on it, and is now the US Department of Energy, I think it's MIT, working with the US realtors and valuers of how to actually value. So they're working on working the formula. Now, once that happens over there, that'll sweep through it all. And they're quite serious about it. So it will be coming out. And once they're starting, because they're talking not just to valuers, they're talking to banks. So the banks are going to take it into account in their valuing places. And once that starts happening, that'll sweep through.
Yeah, I'm going to be very sad in Sandringham now. We'll remove the air conditioners, but when they come and bulldoze all the double glazed windows, I'll be really sad. Old weatherboards not necessarily hang around along in Sandringham anymore. Steve?
We live in a strange place.
Robert?
Melbourne, I mean, yes. Where not far from us, there were 2 houses sold recently, or actually one house and a vacant block in the same street. And the vacant block sold for more than the perfectly reasonable house. So when you talk about resale value, you've got to allow the crazy factor in there somewhere. That's one thing. The other thing is, has anyone done any work on solving the problem that you alert us to? The colder it is, the harder the heat pump is to work. So in places where you need a lot of heat, alpine areas or perhaps southern Tasmania, you're using this thing a lot more, and it might be worth spending a bit of extra dough to alleviate that particular problem, so that you can actually run your heat pump more towards the middle of the day and use your heat whenever you want. And the way to get that time separation would be with a rock pile, for instance, a rock store inside the house. Now, you wouldn't do that unless you had considerable use for it, but it's a very efficient technology.
Yes, and we posted some of that stuff on the discussion group. In fact, Canada, they use those things a bit, so they call them thermal banks.
Yes.
So there's things that do exist other places, generally in more severe climates, like you say. And the other thing you do see, this is an air source heat pump, but there's also the ground source heat pumps, and you see those on the lifestyle shows in the UK. They're running pipes through the dirt and everything because they'll be looking to capture heat from the ground, which is more stable temperatures than the air temperatures in the UK. But for most of Australia, outside of the alpine areas, the air source heat pump can work fine. See?
Just answer my question. It was about geothermal heat pumps and whether there are any manufacturers making them for domestic use in Australia.
Gosh, I'm not
exchange to the ground.
Melbourne Uni had a program on to heat a building or something, so I think that's the stage where that's at.
The industry does it every now and then.
But I've not heard of a home in Australia.
There's lockdown Glen Hunter, that doesn't, I'm trying to remember their name, but they're Glen Hunter Road.
Geo Exchange?
Yeah.
Question out of that?
Have you started chatting with the Victorian government on the potential for extending the existing building codes to include reverse cycling issues?
Yeah, it's talked to a few different stakeholders in the Victorian government, including some of the Premier's office. Well, it's Tim Sonway, he used to be the Clean Energy Council, so he's and there's not been any pushback, so people do realize that the economics are changing. It used to be like in public housing, that sort of thing. You didn't want to give somebody an air conditioner because they might use it. And so what I'm saying is, what I said to these folks, and they seem to be taking this on board, is for like public housing, they'll give people an air conditioner. Yes, they'll use it in the summer, so they'll actually survive the summer, but then they can actually use it in the wintertime as their main heater quite cost effectively. And so the government doesn't need to provide a gas heater. But the gas heater, of course, public housing, you have to go in there and make sure that, for any home, have your equipment service to make sure you're not poisoning yourself with carbon monoxide from poor operation of gas units. You should have the gas units looked at every 2 years with that concern. So then, the public housing, they can just eliminate all those issues if they don't have gas coming into the properties. So they're looking at those sorts of things.
There's some time for one more question if there's anything.
Just I guess the fellow down the back doesn't have a chance.
Just a leak right out of this excuse me, to me, perhaps too fanciful. We're talking about using ambient energy. Now, you're just putting solar cells on all the houses, and this is only one option. Why can't we use ambient energy to heat and provide electricity to houses or to businesses?
That takes me back.
I mean, you have to build technology and you have to add the extra heat. You have to add that.
What's that called? That's called a Stirling engine, isn't it?
It's an old, well, it could be Stirling, it could be an old engine, an old engine. An organic banking engine, so it is. This is an organic banking engine using the same refrigerant. Probably, I'd like to see a system where you could have the compressor and the organic banking engine in the same circuit.
I know that with the organic cycle, they've had difficulty making the economics work for power generation when they had access to 200 degrees C energy. That's shallow geothermal.
So it should be simple with this.
But not economic, it seems, so far, compared to the other options.
There's so much ambient heat.
Yeah.
Why can't they some have collected? I know it's fanciful, I'm leaving away from this idea that you were putting here.
The shallow geothermal is a possibility. The economics just aren't there at the moment for people chasing.
Just a thought, leaving away from, just opening up to the possibility. Thank you.
Okay, great, thank you. So let's please formally discussion. We'll have a drink and a meal at the pub. What's the name of it, Mila?
The Glade.
The Glade's down the road there, so please come along if you've got the time. We'd also like to plug of course, BZE being a non-profit organisation is keen for any contributions, and our baseload supporters are the lifeblood of our organisation and provide us the funding we need. So please go onto our site at bze.org.au to find out more. You can also see a video of all the discussion groups, so there's a lot of the previous discussion groups there as well. And of course another reminder of our community radio show that runs twice a week. Our next discussion group is on the 4th of July. The venue will be here. Our guest is still to be decided, but get onto our website, sign up for the mailing list, and you'll hear all about that. And the last thing we're going to do, well, second to last thing, is I'm just going to give a quick plug to this Coal and Climate Change Federal Election Candidates Forum in Boxfield Town Hall. So there'll be a lot of the candidates from that area, as well as Mark Butler, the Shadow Minister of Climate Change, Janet Rice from the Greens, Josh Frydenberg, and Peter Christoph from Melbourne Uni as well. So plenty of people just come and see their story.
Tell them the date.
The date is the 16th of June at 6:30 for a 7 p.m. start. And there are some other brochures out the front there if you want to just grab that flyer on your way out.
Thursday.
It is a Thursday, yeah.
We've also got a couple of the flyers, which just like walls or notice boards. Anybody wants to? Yeah.
So, yep, okay. And lastly, we're going to do the draw. Tim, you want to do the
There we go. We've got B01, block 01. And there's a phone number, 409-806-604.
We got it.
Yeah.
Oh, well, maybe we should. Let's do it. The person's here. So make sure you get it off mute, and we'll.
Mr. McGurn, is it?
It's like 409. 604.
That's amazing. All right. So there's plenty of stuff in there. This discussion earlier about the discussion was mainly on air conditioning and things tonight, but really everything about getting a zero carbon home around insulation, double glazing, drought proofing, solar, all that great stuff. So thank you very much again, and we'll see you at the pub.